Welcome to electron Trying to find an explanation of what a photon is, let's go take a look at what a photon can do in an atom. So let's say we have a hydrogen atom here. We have a single proton that's the center, the nucleus, and then we have what we call energy levels around the nucleus. And typically the electrons in the atom will reside in the innermost energy level. They want to be in the lowest energy state. And of course in a hydrogen atom there's only one electron, and that electron will usually be situated inside the innermost energy level. That's the K level, the K shell, where we have the S1 orbital. Now the energy level of that first level in hydrogen is at minus 13.6 electron volts. The second energy level is at minus 3.4 electron volts, and this should be the third energy level is at minus 1.51 electron volts, and the fourth energy level is at minus 0.85 electron volts. So in order to get an electron, let's say from the first level to the second level, you have to infuse a certain amount of energy. How much energy? The difference between the energy level of the first and the energy level of the second level. So what would be the difference between 1 and 2? So the delta energy going from 1 to 2 is equal to minus 13.6 electron volts minus a minus 3.4 electron volts, which is equal to a minus 10.2 electron volts. Now, of course, that depends which direction you go. In other words, if you want an electron to go from the first level to the second level, you will have to give it 10.2 electron volts of energy. And if an electron goes from the second level back down to the first level, it will give off a 10.2 electron volts worth of energy. So in order to move an electron from one spot to another, from one energy level to another, it needs that amount of energy. Where does the energy come from? It can come from photons. For example, a photon can come along that has the exact amount of energy. How much energy? Exactly 10.2 electron volts. If it does, that electron will absorb that photon and use that energy to jump to the next level. If after a little bit of time, maybe 100 millionth of a second or so, it decides to fall back down to innermost energy level, it will then give off a photon of that exact energy level. So it turns out that photons can interact with electrons. They can hit an electron and make it move if it's not in an orbit, it's just out in space, or if it's in an orbit of an atom, a photon could come along and that electron can absorb that energy of the photon and use it to jump to another energy level. But the jumps have to be quantized, because if the amount of energy in the photon is not exactly equal to the difference between those two levels, the electron will not absorb the energy and will not make the jump. Likewise, let's say we have an electron that is in the fourth energy level, and for some reason it jumps all the way down to the first energy level. It can do that. Sometimes it jumps one at a time, sometimes two at a time, in all kinds of different situations. It's kind of like marbles falling down to a lower level, and sometimes the jump can be in one jump. So what would happen if an electron jumps from the fourth energy level down to the first energy level? It would give off a photon of that exact energy difference. So it would be exactly the difference between 0.85 electron volts and 13.6 electron volts. Since we talk about the difference, we just talk about the absolute value between the two. So let's calculate what kind of photon would be generated or would be needed to make an electron jump from the first level to the second level. So we need a photon with this kind of energy. So the energy of a photon, we know, is equal to the h constant times the frequency, which is equal to h times c over lambda. So the wavelength would be equal to hc divided by lambda, by energy. I want to put the energy there and put the lambda there. So definitely what I wanted to write down here was energy, not lambda. All right, so let's plug in the numbers. That would be 6.626 times 10 to the minus 34 joules times seconds. Multiply times the speed of light, 3 times 10 to the 8 meters per second. And then we divide that by the energy required, which was 10.2 electron volts. And of course, we want to convert from electron volts to joules. That would be 1.6 times 10 to the minus 19 joules per electron volt. All right. So 6.626 e to the 34 minus times 3 e to the 8 divided by 10.2 and divided by 1.6 e to the 19 minus, and we get 121 point, wow, I need my glasses for that, 121.8. So the wavelength would be equal to 121.8 nanometers, which of course would be a photon of ultraviolet light or ultraviolet radiation. So if a photon of this exact wavelength with that exact energy, 10.2 electron volts, comes down, strikes an electron in a hydrogen atom in the innermost energy level, that photon would be absorbed and the electron would jump to the next level. And likewise, if an electron falls from the fourth level down to the first level, what kind of photon would it generate? Well, the difference in the energy going from 1 to 4, that would be equal to 13.6 electron volts minus, let's see, the fourth level would be 0.85 electron volts. And again, we're just looking for the absolute value between the two. So this would be equal to 12.75 electron volts. Yep, that would be correct. So converting that to a wavelength, we can say that therefore the wavelength would be equal to hc over energy, which is equal to 6.626 times 10 to the minus 34 joules times seconds, multiplied times 3 times 10 to the 8 meters per second, and dividing that by the energy, which is 12.75 electron volts. And of course, converting that to joules, 1.6 times 10 to the minus 19 joules per electron volt. And so we would see then what kind of photon would be generated when an electron jumps from n equals 4 level to n equals 1 level in a hydrogen atom. So 6.626 e to the 34 minus times 3 e to the 8 divided by 12.75 divided by 1.6 e to 19 minus equals, and that would be a photon with a wavelength of 97.4 nanometers, which is 10 to the minus 9 meters. So there's another interesting look at what a photon is. A photon is a chunk of energy that can be responsible of being absorbed by an electron and therefore making it jump to a higher level, or it can be a chunk of energy given off by an electron when it jumps from a high level down to a lower level, to a low energy level, and then releasing a photon with that exact energy difference. That's what photons are. Photons are carriers of energy, and that energy, when it arrives somewhere, can be utilized by electrons to do something with it, or if an electron jumps to a lower energy level, it can give off an electron with that particular photon with that particular energy. Even any kind of quantum jump in quantum mechanics, any kind of particle that goes from one state to another state, if it's from one energy state to a different energy state, if it goes to a lower energy state, it will give off a single photon with that energy difference. If it goes to a higher energy state, it will absorb a photon of that exact energy difference. And that's how photons allow these things to happen, because it gives the material, it gives the atoms, the electrons, the protons, the quantum mechanic particles, it gives them what they need to exchange that energy to allow them to make those quantum jumps. So photons are basically the facilitators of quantum jumps in nature. And another look at photons.